Possible causes of current imbalance. Voltage imbalance, we just talked about that. Open rotor, pretty rare. It's just a defective iron in the rotor of the motor itself. Compressor surge, if your compressor surging, you're going to see imbalances. System load changing, you may have controls or a system that's constantly hunting, and that can cause some imbalances once in a while, which I guess the same thing as inlet vane hunting, which could suggest a control system malfunction or water flow that is changing dramatically. This happens to be some rules of thumb I left in for a trained CVHE chiller. You want to look at your particular chiller, and even if you've got a newer CVHE, to see what the temperatures they're suggesting are. But it tells you when you're logging oil temperatures where you ought to be on the different types of chillers. So let's talk a little bit about, you've been doing these data logs, so what? You know, what are some things I can look at from the condenser when I'm evaluating your condenser as to what may be wrong? Or I can point out before you shut down. And one is insufficient water flow. Another is excessive water flow. And I'll talk about these a little bit more later. High condensing water temperatures. Waterside tube fouling. You could have air in your water circuit, restricting some of the water flow. You could have pass-to-pass leakage. What that is if you like have a two-pass chiller with both the supply and return on the same head. The water goes in half the tubes, comes around and through the other. There's a partition in that one head, and sometimes if the water's corrosive enough, it will eat up that partition, and you have the water, instead of going through the chiller, just short circuits the chiller. Tube blockages and restrictions. Condenser water piping reversal. You're going to find this out of chute, hopefully, at startup. But condenser refrigerant side problems, which could be non-condensables, air in the refrigerant circuit, or a restricted refrigerant orifice or expansion device. On the evaporator side, you could have a lot of the same problems. Pretty much all these are similar. Chill water temperature problems. You could have refrigerant contaminants, external tube fouling, and low refrigerant charge. It's usually in the evaporator that you can determine with your approach temperature and other information if you got a low refrigerant charge or not. These other two are worth mentioning. Refrigerant contaminants can look like a lot of little things, but the biggest culprit is oil, refrigerant oil. You can have too much refrigerant oil in there, or it's getting logged into the evaporator, not getting back to where it needs to. Now, here's another rule of thumb. For every 1% increase in oil that you have in your evaporator, it's a great insulator. It coats the tubes really good. It'll cost you about 2% of chiller efficiency. So I remember we're having problems with one chiller. We ended up, instead of doing oil analysis, in addition to oil analysis, they paid quite a bit more to get a refrigerant analysis done. We found they had 16% oil in this machine when they should have had at most a couple. It was cost them a fortune on efficiency. External tube fouling. Most people today on new chillers have rifled tubes. They're internally rifled, right? Most of the chiller manufacturers, to optimize their efficiencies, also have their tubes rifled on the refrigerant side as well. And the rifling is optimized for that particular refrigerant, to optimize to the boiling characteristics of that particular refrigerant. There may be fouling on some of those too that's causing the boiling of the refrigerant to not be as efficient. Years ago, I put some charts together with the help of a few of the technicians I worked with, and said, okay, how would you determine if there's an insufficient water flow? And we put all the possible things that you're reading and you're analyzing in a log sheet. So a high approach temperature on your condenser. Again, if your condenser design was 7-degree approach temperature and you're running 10, then you might have some of these problems. Okay? Again, that's the difference between the condenser refrigerant temperature and the water leaving the condenser itself. If you have a low approach temperature, you may have a problem, you may not, but if it's supposed to be 7 and you're getting 2, you may want to make sure you have sufficient water flow. High water temperature difference, it's coming in at 85 and going out at 100, you know, and it's supposed to be at 95. You may want to look at either 2 blockage restrictions or insufficient water flow. Low water temperature difference, just the opposite. You know, you're expecting to go in at 85 but come out at 95, but it's coming out at 87 or 88. You may have too much water flow or a pass-to-pass leakage. High refrigerant condensers, pressures, and temperatures. Boy, there's all kinds of possibilities there. If the compressor is surging, you have some possibilities as well. High water pressure drops. That pressure differential across that condenser is too high. You could have excessive water flow or restrictions. If it's too low a pressure drop, you could have pass-to-pass leakage or insufficient water flow. If you have a pressure temperature imbalance, if you were, instead of just getting a calculated refrigerant pressure on your machine, you're actually having a transducer measuring a condenser refrigerant pressure, and you are getting a condenser temperature reading, you can compare those in a chart and see if they match up. And if they don't match up and your pressure is running higher than it's supposed to at that refrigerant temperature of, say, 102, you may have air in there, non-condensables. You have air in the condenser. So now you can identify all the different issues you are experiencing at one time and come down here and have a good probability of where to start searching. Again, you can do this now rather than wait until you shut down and it's 100 degrees outside. I'm not going to get into all the details, but we got the exact same thing here. The only difference might be refrigerant contaminants. You have a high approach temperature because you've insulated those tubes, and the refrigerant temperature is 10 degrees when it should be 7, and a low refrigerant temperature. So if you have those two, plus I'm not sure if that it needs to be, but if you have these two, you may want to check on the percentage of oil in your refrigerant. Otherwise, it's the same discussion as with a condenser. ASHRAE, now this is a dated deal. I'm sure ASHRAE's come up with a later version of their Guideline 3A. But ASHRAE Guideline 3A suggests what you should do to maintain your chiller. And they are saying that if you're doing your chiller maintenance right, you are doing daily logs, at least, of all this data on your chiller, if it's valid for your chiller. Again, I'm focusing on water-cooled. You have air-cooled logs that would be the outside air temperature and the refrigerant temperatures and pressures, you know, instead of the water flows and that. So, again, ASHRAE is saying you should be doing this. Now, a lot of people say, well, heck, I got it on my display now. What do I care? You know, it's all computerized. Well, I personally think that it's just as important today in the age of microprocessors to do daily logs as it's ever been. These machines are in some ways too smart. Machines now have adaptive control logics. What does that mean? That means if they're starting to hit a problem and you're starting to get tube fouling in a condenser and they can't load up all the way without tripping, they will intentionally throttle back and not allow themselves to fully load, even if you need it. So they're going to keep themselves online for you. Hopefully they give you some kind of alarm to tell you you ought to check something out, and hopefully you check it out. But Nonetheless, they're going to stay running and lop along at that 70% because they can't go fully loaded. Well, guess what? If you're not doing your daily logs and catching these things, what's going to happen? You're going to have the 100-degree day, and you're going to need a 100% chiller, and you're not going to get it. And now it's an emergency call.
Hey, Mike?
Yeah.
Do the newer microprocessors and the newer chillers have the ability to trim that stuff and actually kind of fill out some of these logs for you, or is it still a manual?
You know, it depends on the manufacturer. Now, what a number of them do, if you buy the front end and tie it into a building automation system, some of them have this capability that you can turn on, some don't. Okay? A lot of them, what they'll do is they'll have an option to buy a printer option, and you can plug a serial port printer into the panel, and it'll automatically dump a printout of your deals. But again, the problem is, here's a printout of that snapshot today. Here's another piece of paper of tomorrow. Now, unless someone takes that and puts it on that log where you can just look right there and see trends, it doesn't help you that much. But there is more and more manufacturers offering, usually there's some extra front ends, programmings, interfaces, or whatever to capture this. But it's worth asking that question of your chiller manufacturer. Again, why run daily operating logs? Again, I started talking about the cost of having too much oil in there that you can identify early. Why wait until you shut down on a failure or can't keep up in August to have someone come out and work on an emergency basis when it's costing you that, 2%. What does 2% cost you? I wrote that down. On a 400-ton chiller, if you had 1% too much oil in a refrigerant, for every 1%, it'd cost you $960 to $2,000 a year, operating cost. Why wait till it shuts down and then address it? You can be saving money by addressing it earlier in the game. 1 degree of additional lift can cost you $700 to $1,500 a year. 1 psi of air in the condenser, that non-condensables, can result in a 3% efficiency loss, and that could be $1,400 to $3,000 a year. That is why I encourage daily logging, ideally twice a day, mid-morning and mid-afternoon, but at least daily logging. Typically at the same time, when the unit's stable, and when the tech's coming in, you'll tell if he's a good chiller tech or not. He'll actually look at your logs. Okay? With that, I can open it up for questions. Thank you.
If your tubes are valved on the refrigerant side, what do you do?
I don't know. I would assume that you would, depending on the fouling, that you would probably evacuate the charge, pull deep vacuums on it, see what the fouling is. Usually it's, it's oil or water or something. There's got to be something. It's usually not as physical as it is fluid type. But the first thing you do is you got to pull all the charge, pull a deep vacuum on it, and see if that makes a difference. If it's more than that, you may have to retube, but that's step one. Okay, either I did a real bad job or a really good job, but thank you very much. I appreciate it. I think